Trig 8.3, the product and quotient theorems. Why are we even learning this poor stuff? Well, it's because it makes some things very, very easy. Let's first of all, if z sub 1 is equal to r sub 1 times cosine theta sub 1 plus I sine theta sub 1, and z sub 2 is equal to r sub 2 cosine theta sub 2 plus I sine theta sub 2, then their product, z sub 1 times z sub 2, is r sub 1 times r sub 2 cosine theta sub 1 plus theta sub 2 plus I sine theta sub 1 plus theta sub 2. So to multiply two things together, you do multiply the magnitude, or the r's, the distance from the origin, but that you can do on a calculator if you need to. It's all this other stuff. But all you have to do is add the angles. Cosine theta 1 plus theta 2, sine theta 1 plus theta 2. Makes it a lot easier. This, if we write this in that shorthand, this is really cis theta sub 1 plus theta sub 2. And that's if you multiply two of them together. So you multiply the distance from the origin for each and add the angles. And then you can find the sine and cosine of those. So what do you do for the quotient formula? Well, it's similar. If z sub 1 is equal to r sub 1 cosine theta sub 1 plus I sine theta sub 2, and z sub 2 equals r sub 1 cosine theta sub 1 plus, sub 2 sine theta sub 2, then z sub 1 over z sub 2. Now, we multiplied before when we took it to a power. Now we're going to divide, so this follows the operation r sub 1 over r sub 2, these two. But then, what do you do with the cis? When we multiplied, we added. When we divide, we subtract. Theta sub 1 minus theta sub 2. And boy, that makes dividing pretty easy for these complex numbers. Especially if you have to do it over and over and over. That's really all there is to section 8.3. There are some, I guess, if you take z, which is just r cosine theta plus I sine theta, then z to the nth power is r to the nth cis n theta. That's what makes this. Take it to the power 10, you just have to multiply by 10. You still have to take this r to the power 10, but it's not as difficult as all this stuff. So this is the special case for powers. Now there's also in section 8.4 the Morphs theorem. And this is what he says. Suppose r cis theta is an element of the set of complex numbers, and n is an element of the reals, then r cis theta to the nth is r to the n cis n theta. So this is what I was talking about before. This is a whole section on this, but it's really nothing new. So de Morphs is the one who figured this stuff out that we talked about in that last part. It's really more important to do roots of complex numbers. Now, when you find the square root of something, there should be two answers. The cube root should have three answers. The fourth root should have four answers. The fifth root should have five. In the real numbers, you may not get all those. And almost always you don't. So, how do you find the roots? Well, we're going to start similar to this. We're going to say it's r cis theta, not to the nth, but to the 1 over nth power. That fractional exponent is like taking an nth root. So you do need r to the 1 over n power. That's what we've been doing all the time. But now you're going to take cis, cosine I sine, and your angle is going to be theta plus 360 degrees times k over n. So, why do you need this 360 in the k? You could also use 2 pi here, 2 pi k, if you don't want degrees. K is going to change. It's going to go from 0 to 1 to 2 to 3 up to n minus 1. So if it's 3, it'll go 0, 1, 2. It'll still give you 3 roots, but n will count starting at 0. So what does this mean for roots? That means you'll get all of the roots. You'll have to do this 3 times, 4 times, 5 times. Let's see if we can do one for you. What if we find the third roots of unity? What in the heck does that mean? We're going to take the complex number 1 plus 0i, that's unity, 1. And we want to find the third roots of that. So it's to the 1/3 power. And there should be 3 answers. Now we need to come up with our r and our theta. So where is this point? Well, it's at the point 1, 0, right? What is r? That equals 1. What is theta? Well, since it doesn't move, theta equals 0. We'll do this in degrees. So we've got r and theta, we've got everything we need. K, for the 1/3 power, is going to go 0, 1, 2. So if k is 0, then you got r to the 1/3 power, but r is 1. 1 to the 1/3 power. Cis. Now you've got to do this theta, which is 0 degrees, plus 360 degrees times 0 over n is 3. What is that? Well, the third root of 1 is 1. This is the angle 0 because you got 0 plus 0 over 3. So this is just 0 degrees. If k is 1, then it's still 1 to the 1/3. That doesn't change. R to the 1/3, cis. But now it's the 0 degrees plus 360 degrees times 1 over 3. So this is 1 cis This is just 360 divided by 3, right? Which is 120. And when k is 2. So it's still 1 to the 1/3 power. Cis. It's 0 plus 0 degrees plus 360 degrees times 2, or 720. So let's see here. We get 1 cis. The 360 times 2 is 720. Divided by 3 is twice. There's 6, 1, 12. 312 is 40, so it's 240. So this is the angle 240 degrees. These should make sense. If you think about where those are on the circle, the 0 degrees is here, the 120 degrees is here, and the 240 degrees is here. And even though mine's a little sloppy, we've really broken this circle into 3 different but equal pieces of pie. And that's what we've done here with this root. Does that make sense? A little bit of sense? That's probably the most we're going to do from that section. So I'm going to put these together, 8.3 and 8.4.